All the stars that we see in our night sky are from our own galaxy, the Milky Way. In fact, the furthest star we can see with the naked eye is a star called V762 Cass in the constellation of Cassiopeia at a distance of 16,308 light years. To see individual stars beyond our galaxy, we need a telescope. And the most popular orbiting telescope was used to spot the most distant star ever detected. It is known that the galaxy clusters magnify background objects through strong gravitational lensing. Typically, the magnifications are a factor of a few, but in some cases, they can be tens or even hundreds, stretching the background objects into giant arcs. Due to the sheer fortunate alignment with the lensing cluster and the Earth, individual stars can attain even higher magnifications. In an earlier video, I talked about Lazarus, which was the most distant star ever to be observed in a galaxy about 14 billion light years from Earth, which was at a redshift of 1.49. Redshift in cosmology is the displacement of spectrum of an astronomical object toward the red end of the spectrum. This shift in spectrum happens due to the relative velocities between the objects we observe and us, the observer. In the case of very distant objects, the value of redshift gives us a measure of how fast the universe between us and the object is expanding. So, a larger redshift number means the universe between us and the object is expanding at a much faster rate, and hence the object must be much further away. The record for the furthest star ever discovered was just broken, yet again by the Hubble Space Telescope. WHL 0137-LS, also known as Earendel or Morning Star in Old English, is now officially the most distant star to be observed at a redshift of 6.2 plus or minus 0.1. This star formed in a galaxy just 900 million years after the Big Bang. The gravitational lens caused by the foreground galaxy cluster WHL 0137-08, which is at a redshift of 0.566, has magnified this star by a factor of thousands. The correctness of this observation has been verified by 4 independent lens models. The observed magnification and the brightness of this star have remained fairly constant over the last 3.5 years of continuous observations using the Hubble Space Telescope. The study also found that the D-lensed absolute ultraviolet magnitude of this star is minus 10 plus or minus 2, which is consistent with a star 50 times the mass of our Sun. This simple calculator lets us estimate the life of a star based on its mass. If we put in 1 solar masses, it shows that the star can live for 10 billion years, which is the total lifespan of a Sun-sized star. Given that our Sun has been around for the last 4.6 billion years, it has approximately got another 5 more billion years to go. If we put in 50 solar masses, which is the mass of Earendel, then its life is calculated to be 0.566 million years, which is very short, and that is true. The larger the star, faster it churns through its nuclear fuel. Given the mass of Earendel, we know for sure that by now it would have turned into a black hole. In this image, Earendel is the star indicated by the arrow. The red dots on either side of Earendel are one star cluster that is mirrored on either side of the ripple in space-time that gives Earendel the extreme magnification we see. The entire galaxy, called the Sunrise Arc, appears 3 times, and the knots along its length are more mirrored star clusters. This discovery is so important and interesting that further investigations of this star and its spectral classification are already been approved with the newly commissioned James Webb Space Telescope. I will leave a link below to the draft version of the paper announcing this phenomenal discovery.